Our study entitled Microstructure, Mechanical and Fractographic Behavior of the Diffusion Welded Joints of AA2219 and Ti-6Al-4V for Aerospace Applications. In the diffusion welding method, the two joining surfaces are stacked together at a temperature of about 70 to 90% of the absolute melting temperature of the base metal, and an optimum pressure is applied for an adequate holding time to get the diffusion welded joints. These are the materials and methods which are incorporated in the current study. BSC images of the diffusion welded joints produced at 30 to 120 minutes are shown here. Many scraggly voids are observed on the interface when the holding time was 30 minutes. However, the AMC layer is observed when the holding time increased to 60 minutes and more, with the elimination of irregular voids. When the bonding time increased to 120 minutes, the plastic deformation of the interface is observed. The line scan area shows the diffusion depth at the interface of the welded sample. The diffusion depth is also increased with an increase in the holding time. Shear strength is increased with increase in the holding time until 90 minutes, and then after it is gradually decreased when the holding time increased to 120 minutes, elucidating the effect of brittle IMC formed at the interface. Similarly, the micro hardness is evaluated across the joint interface, and it is observed that the hardness at the joints is increased with increase in the holding time. The increase in the hardness is mainly attributed to the formation of hard intermetallics. Fractured surface and their fractography is shown in the figure. The XRD curves clearly indicates the formation of intermetallics such as Al3Ti, Al2Ti, AlTi in addition to the pure Al and Ti peaks. These are the conclusions drawn from the current study. Maximum shear strength of 143.58 MPa is observed for the joint formed at 90 minutes, and it is decreased when the holding time increased to 120 minutes. The joints predominantly failed between the Al and the reaction layer formed towards the Ti side, ensuring the brittle types of failure. The fractured surfaces on the Al and Ti sides illustrate the primary features like dimples, cleavage, cracks, voids, and tear ridges. The authors are greatly thankful to the Research Promotion Scheme AICT New Delhi for financially supporting this study.